everyone, welcome back to the video series of statistics in machine learning. In this video, we are going to talk about random forest. In the last video, we talked about bagging as one of our ensemble method. Here, we'll see how random forest is better than other ensemble methods. So let's have a look at it. Now, random forest is another ensemble method, just like bagging. It can be used for classification and regression, but it is observed to provide highest accuracy among all the ensemble methods. So why random forest is so good? When we are creating a decision tree, we use the strongest predictor for the split, which we can measure via Gini index if we are doing classification. So when we create multiple trees, our split will always be across the same feature, which is the strongest feature, making the trees look alike. This leads to having highly correlated trees, which makes the loss in variance insignificant. And to avoid such scenarios, we use random forest. So why is random forest so good? When we are creating a decision tree, we use the strongest predictor for the split, which we can measure via Gini index if we are doing classification. So when we create multiple trees, our split will always be across same features, making all the trees look alike. This leads to having highly correlated trees, which makes the loss in variance insignificant. And to avoid such scenario, we use random forest. So how does a random forest work? It generates uncorrelated trees. But how do we do that? We restrict the numbers of features for splitting. Usually for classification, we keep the square root of the total features and 1/3 of the total predictors for regression. Since now the strongest predictor won't be always used for splitting, we may give chance to moderate predictors to construct the trees. We keep the value of m such that the correlated features we have to consider for splitting are least. So just like bagging, random forest doesn't suffer from overfitting, so we don't need to worry about pruning. And the large number of bags reduces variance. So now we know when to use random forest, but when should we not use random forest? If you visualize the decision boundary constructed by decision trees, they are always perpendicular. Hence, if our decision boundary isn't like that, random forest will fail to classify. Secondly, in regression, if our testing data has predicted value which is larger than any training data, then random forest will yield wrong results since the regressed value will be the average values of the terminal nodes which are smaller than the largest value. So that's it from this video. Hope you liked it and understood the concept of random forest. For any doubts, feel free to contact me on LinkedIn. My profile link is in the bio. Bye bye.